Pooja Singh, Relearn Geology. Here I am going to teach you about the SP log. Earlier I have given some introductory video regarding the well logging. Now I am going to teach you about this SP log, which is a self potential log. So what is a self potential log is basically, so here there are two electrodes being used. One is fixed at the ground and one is directed in the well well bore, where it takes the reading, and it takes the natural reading of the formation. That's why it is called as self potential log. There is no external current is being applied while taking the reading. That's why it is called self potential log. So basically it tells about the salinity of the formation. It means it is the reading of the salinity of the formation, because it is a relative kind of thing, where the salinity of formation is being compared with the mud filtrate, and that's why it tells about the salinity of the formation, whether it is more saline or less saline, whether it is more saline or less saline as compared to the mud filtrate. And third point is the presence of hydrocarbon in the formation suppresses the SP deflection. Yes, it is true, because hydrocarbon is more resistive than the water with ions present in it, because hydrocarbon is simply a hydrogen and carbon chain, whereas water consists of some ion. So water will let the current to pass through it, whereas hydrocarbon suppresses the current. So if the hydrocarbon present in the formation, there will be less current will flow. There is I'm not saying that there will be zero current, zero deflection, but yes, it is obviously suppress the normal SP deflection. So there are two terms basically used in the whole SP log, is RMF and RW. So RMF is the resistivity of mud filtrate, and RW is the resistivity of water. Mud filtrate is something which is used external, and RW is the resistivity of formation water. Now resistivity is inversely proportional to conductivity, you all know that. Hence the salinity, more the salinity more it will be the conductivity. You all know, you can relate with that, how salinity is useful, very good for to let the things to be conductive. So basically there are two conditions while reading the SP log, that is left deflection and right deflection, and for that there should be certain things, like if RMF is greater than the RW, which means mud filtrate is less saline than formation water, and vice versa if RMF is less than the RW. For first condition, that is when RMF is greater than RW, as SP deflection is towards RW is resistivity of formation, which is always towards the left side of the left side, which is the formation water, and which is negative, and positive when RMF is less than the RW, that is towards. I think it is while reading it is quite confusing, so I'll tell you in the simple words. So as per convention, or mostly you can see the mud filtrate, that is the mud which is being put in the well, is from the outside, and is always in the right side, and formation is always represented in the left side. So if the mud filtrate is more saline, that is it is less resistive than the formation water, then the obviously the current will pass through the more saline thing. So the deflection will be towards right direction, that is your mud filtrate, towards mud filtrate direction. And similarly, if the formation water is more saline than the mud filtrate, then the deflection will be towards left side, which is negative side. uh, that Because your formation water is represented towards the negative side of the well bore. Generally it has been taken. Now I have explained what is hydrocarbon separation in the earlier slide. Now I read it once for you. So hydrocarbon separation, if there is presence of hydrocarbon, oil or gas, then it is more resistive than the mud filtrate, so it will deflect less or suppress the normal SP curve when water is present which contains ions. So I think this is a quite explanatory in itself, so I need not explain it in a very elaborate way. Now coming to SSP, there are few terms we must know while studying the SP log, that is SSP and PSP, which is very useful while calculating the sail volume. So what is SSP? SSP is static self potential. That is when there is a clean permeable sand, that is clean formation. It gives a maximum SP deflection for the water present in it, that is called SSP. And what is sail baseline? Sail baseline, generally you know that the pure sail is a impermeable rock, and when anything is impermeable, it will not let the mud filtrate, or it generally contains less water except the water bound thing. Not I will not talk about the bound water, but generally imagine the sail which is less permeable, which is impermeable basically, which do not let the water to come into it, so it will show the zero deflection then, and that zero deflection is called sail baseline. Most of the SP deflection is taken relative to that particular cell SP, your sail baseline. Now coming towards the pseudo self potential, when the formation is contain little, for example when sandstone contains little sail in it, and then some sail is then that particular sail uh, resist the current to pass through it, uh, and that is also being little being suppressed than the normal SSP curve. So that is your pseudo self potential, which is little being suppressed than the SSP. So that is your pseudo self potential. And how this cell volume is calculated by using SSP and PSP. It is when the ratio of PSP and SSP is being subtracted from the unity, you can calculate the cell volume easily. There are more things to tell, which I must have to include in the this particular whole slide, but there must be thing you must do it on your own. Do some research and read a good book like Rider, so that you have a better idea on your own. You can revise things, and it is only helpful video, it will only help you to have some better basic concept. So that's all for today. Thank you very much.